Hi, I'm Dustin Carlino from the Alan Turing Institute in London, and today I'm going to very quickly tell you about a project called AB Street and how it uses OpenStreetMap. So AB Street is a project with many pieces. One of the pieces is a traffic simulation. So here you can see individual drivers, cyclists, and pedestrians moving around a traffic-controlled intersection. And so as a traffic simulation, it's very visual and sort of designed for use by the general public and not just a very technical audience. And this is another picture of the traffic simulation at a larger scale. You can see a very unusual traffic jam form and kind of dissipate. So what AB Street lets you do is express your ideas for reallocating road space. And so maybe you have a 4 or 5 lane road that doesn't need that many lanes. And so you can make some transformations and add maybe protected cycle lanes or bus lanes, things like that. And this uses a very simple interface inspired by StreetMix to let you do that. You can do the same thing for traffic signal timing. So, for example, adding a dedicated left turn phase and kind of specifying the timing at a particular intersection. And so the idea of the traffic simulation is you make these edits to the map, and you can repeat a simulation before and after the changes and sort of measure on an individual basis what's the difference in travel time, delay at different intersections, and also things like risk exposure of pedestrians walking near cars turning at high speeds, or things like cars passing cyclists without separate space. And so the AB Street project has a bunch of other tools. One of them is called Ungap the Map, which helps you quickly plan out cycle networks in places that are that they're needed, and kind of from a travel demand model get a very rough estimate of what the impact on mode shift might be from people switching short driving trips to cycling. There's also some tools for understanding things like 15-minute neighborhoods, what businesses are accessible within a short walk of a place. We've also sort of experimented with simple arcade games to teach the public about the concept of 15-minute neighborhoods in a more fun way. And most recently, we're working on a tool to design low-traffic neighborhoods in sort of a UK context, and this has been used in a few public consultations, such as in Bristol City Council. And so this helps you. So low traffic neighborhoods help you stop vehicle traffic from shortcutting through a certain area. So how do all of these different pieces of AB Street work? They all use OpenStreetMap. And the reason is that we want the tools to work anywhere in the world and sort of rely just on open data sets. And so part of this is getting information about where people travel, but I won't really talk about that today. Instead, focus more on the network model. And so this is called, the piece of this in AB Street is called OSM to Streets. And we're trying to get extremely high level of detail about the roads, kind of as you saw from previous videos. But this is challenging in a bunch of ways. And so this is the web interface to the OSM to Streets project. You can see an intersection in Tempe, and the way it's modeled in OpenStreetMap is pretty complicated. You have sort of a dual carriageway with a center tram track, and you can sort of step through the transformations that OSM to Streets helps you with piece by piece and see it consolidate this intersection into one piece, which is kind of important for understanding the traffic signal timing and the movements through this intersection. You can't reason about this as 4 separate intersections. You need to sort of see it as one. And of course, the transformation here isn't accurate geometrically, but we're working on things like that. And so OSM to Streets gives you sort of a very detailed model of the transportation network. I don't have time to go into it, but in short, roads have a fair bit of detail. Intersections do as well. We kind of have a classification of proper intersections versus things like places where a road splits into a dual carriageway, for example. And yeah, I'll kind of gloss over this. And so the OSM to Streets has a couple of transformations to handle situations in OpenStreetMap that are tough to handle. So for example, sometimes footpaths and cycle tracks are mapped as parallel objects next to the main road. You can sort of see what that looks like before. There's a problem where the sidewalk is on the wrong side of the cycle track. And so in short, we use a combination of graph and geometric properties to detect and fix these situations. And so the repaired situation correctly inserts or sort of like pairs the two roads together and inserts a buffer lane. There's probably some kind of striping or bollards separating the cycle track from the road here. So OSM to Streets is written in a language called Rust, and it's usable from JavaScript, Java, and could be any other languages such as Python and R. We can just sort of make bindings to it, but you can use the project today and sort of export the data in GeoJSON format. And yeah, so another project that I'm spinning up this year is going to try to automatically generate travel demand models and activity models for anywhere in the world using sort of the same principles behind OpenStreetMap. The difference is now we sort of need to first consolidate information about first consolidate census data from a bunch of different sources. So I can talk about that another time maybe. So you should have a link to these slides. Here's a bunch more links if you're interested in any of these projects. All of the work that I do is open source. I'm very happy to contribute with, collaborate with other people working on similar aims. So please get in touch. Thank you.